Hey guys, I just thought of doing a small video to review whatever we have learned in Maths 2 before we appear for the midterms. So let's get back. Let's go to the business first. PV, we have been struggling to learn time value for money. The two principal concepts over here are PV and FV. PV is future value, PV is present value, future value is FV. FV happens to be always greater than PV, and it's actually the appreciated value of PV, or PV is actually the discounted value of future value. So the intuition behind this is this. We have. I would be in a rush because I want to squeeze this to 10 minutes hardly. So uh, what what we'll be doing is that PV most of the time is going to be FV, future value, discounted by the required rate of return, 1 plus required rate of return, to the power, raised to the power periods, that is going to be n. Whatever the number of periods are there in this cycle of investment. uh, Moving on, we discussed annuities, we discussed annuities too. We discussed future value and present value of annuities. We uh, we discussed constant growth annuities. We learned how to move away from the origin and how to find out solve values of cash flows or required rate of return or the number of period by actually using the value, using our basic assumption, which is called NPV equals 0. So let me consolidate all this with examples. Annuities, if someone is asking you that you are depositing 20,000 in your bank for the next 5 years, and at a rate of 5%, what should be the value at the end of 5 years that would be resting in your account? So immediately you know that the future value needs to be calculated for 5 equivalent cash flows, and this is where annuities are usually employed. So what we'd be doing is that you are getting 0, 1, 2, 3, 4, 5 cash flows invested at the rate of 5% in a bank, and you're making 20k investment per annum, and you would be required to find out the future value of an annuity. We have learned this formula, you know the formula, so I'm not getting into that. I just want you to be clear about uh, 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 the application of this. Moving forward, on the vice versa, on the contrary, if uh, if I'm borrowing money from bank, I'm borrowing money from bank, that is 100k from a bank to be amortized in 5 years, and the bank is charging me 10% maybe for against this loan. What should be the annual equal payment I should be making to the bank? I should be making to the bank. I need to know this. I need to calculate this. This again is an application of annuity, but I would be using the present value of annuity. And that present value of annuity happens to be what? If we draw the timeline, I am getting 100k from the bank, and I need to make 5 payments back to the bank at time 1, 2, 3, 4, 5. Okay, here are this is the end. This is period 5, and we are living in time period 0. I need to make 5 equal payments to the bank for the loan that I've drawn at the value of at 10% interest rate. So what I would do is I would use the present value of annuity formula, which is, let me write it down, 1 minus 1 upon 1 plus r power n, divided by what? R. R here, R here is what? We have borrowed at 10%. Again, this 2 is 10%. A is going to be something that we are trying to find out. What should be the equal payment that I should be making to the bank? PV is the present value of the annuity. Present value of the annuity is actually 100K over here. The amount that I've borrowed from the bank, and I'm making equal annual payments, which happens to be A. So annuity, we learned future value and present value of annuity application. Now we should move towards a bit complicated problems. For example, I'm asked, I'm given the cash flows of an investment project or a stock, the pattern of the cash flows, and I'm asked to price that asset or value that asset or find the worth of that asset at present point in time. I'm given that at time 0, the asset is giving at time 0, this is the asset. At time 1, the asset is giving me 2. At time 2, the asset is giving me $2 dividend. At time 3, the 3, and till time 4, I'm getting $2 constant dividends. Then from moving on to cash flow 5, my cash flows are going to increase by maybe 2%. So I would be getting somewhere around 2 into 1.02 power 1, 2 into 1.02 power 2. So up to infinity, up to the life of the project. So what I'm not going to solve this problem, but what I just want you guys to learn that what we are trying to do here, we would be finding out the value of the annuity for these cash flows, the present value PV of annuity of these cash flows 222 by using the present value of an annuity formula. We are going to discount this cash flow at time 1 by what? The required rate of return is 5% given to us. So we are going to discount this to get a value to get the value at time 0. We are going to get the value of PV of annuity at time period 1. The annuity starts at time period 2, but the value that we arrive at is at time period 1. So we get this value, we discount it. We are living in time 0, so we need to discount this cash flow back as well at time 0. And you know how to discount a cash flow back to origin. These 3 cash flows are constant growth perpetuity. There are 2 types of perpetuities. One is constant cash flows perpetuity, where you get the same cash flow all across the life forever, and there are constant growth. So the formula that we have been employing is A1 R minus G. Here R, as we know, R happens to be 5%, G happens to be 2%. 5 minus 2 is 0.03, and A1 is going to be 2 into 1.02, whatever the value it must have been. So we are valuing cash flows 5 to infinity, but we will be getting it at time period 4. And we need to again discount it back to origin by discounting it for how many periods? 4 periods. So the value of the constant growth perpetuity is going to be discounted at time period 4. So I need to make you guys learn something else as well, but I need to make a separate episode for that. So let me conclude it here. See you. All right. So this is the second and the last part of the review that I'm trying to conduct. Now, the more complicated problems are going to move you from your origin. While shifting the origin, the idea behind most of the problems would revolve around 2 things. Across the life of your investment or project or stock or whatever the investment proposition is, across the lifetime of your timeline, you guys, if this is 0 and this is 1, 2, 3, 4, 5, 6, 7, and it can be 80, 70, 90. Just for the sake of simplicity, we are using 7 time periods. So, for example, you would be saving money for these periods, that is, you are making an inflow into your bank accounts. Then you might be needing money for withdrawal for to make to suffice for your living expenses. So the potential paradigm that is going to be tested in these queries, these questions, these problems, is going to be that how are we going to save, how much are we going to save, at what rate, what should be the cash flows to meet the requirement of our future outflows, be it a business proposition. For example, the example that we did in the class, the university's a new department that they were trying to, the university was asked to save certain amount of money, was actually was saving certain amount of money for a certain period of time, invested at a certain rate of return, to make to be able to meet its future cash outflow requirement. uh, on personal front, this guy must have been saving to maybe saving to buy a car, to buy a house. And the cash flows may be varying. If they are constant cash flows, you can use annuity. If they are constant growth cash flows, you can use constant growth perpetuity. If I mean, perpetuity is always for forever, for an infinite time period. But the bottom line, we in such problems which engage positive and negative cash flows, or inflows and outflows, the basic idea would be to operate in present value, net present value equals to 0 equation. We discount every possible cash flow, inflow, outflow at a certain required rate of return to time period 0, and equate it to 0 to find out the missing cash flow or the missing variable that is not given in the question. This is what all you need to know. Rest everything is the proper application of the formula. You need to know that you need to realize that if this is a constant cash flow, you can use annuity. If these are varying cash flows, you can independently discount them to time 0. And you need to realize the most important part that is going to be there would be that at what time cash flow the annuity value is arising to us. Now, for example, this may continue after period 7. This can turn out to be a perpetual annuity, constant growth annuity. So you can employ a constant growth annuity here with positive cash flows. So the the point being, and I might ask, I'm I might give you the value of these two cash inflows, that I'd be saving 40,000, I would be saving 50,000, and how much should I save at time period 3 to make a withdrawal of 20,000 each in the next 4 periods. So this NPV equals to 0 would give you an equation that could make you solve for the missing uh, third cash inflow. That is the third year saving amount that you require to formulate. So, uh, okay. Uh, for example, we have discussed. For example, this guy, I want to buy a car. I want to buy a car maybe in 5 years, and the car is around the car is worth around 50,000. The car is worth around $50,000, right? And I am sparing 5K in the first year. Then in the next year, I'm sparing 10K, 10k, and this year I am sparing certain amount which is not known to me. This is year 0, 1, 2, 3, 4, 5. At the end of 50. So I need to find out how much should I save? How much should I save to be able to buy this car in year 4? Okay. So what this is a typical problem of cash outflow and cash inflows. What we would do is I would discount this cash flow. I would try to find out the NPV. NPV is equals to 0. The NPV would be 5k around, divided by 1 point. The given bank rate is 7% over here. 1 plus 0.07 power 1 plus, if you want to treat these two cash flows as annuity, these two cash flows are annuity, the two constant cash flows, you can treat them as annuity. I am a simple guy. I would prefer to go with the 10 1 plus 0.07 because they are not many. But power has to be 2 plus 10 1 plus 0.07 again power 3. Then the fourth cash flow that is not known to me, I am going to name it CF4. 1 plus 0.07 power how much? 4. And last cash flow. Now that's the tricky part. That's the tricky part. It doesn't have to be plus, it has to be minus. Minus, because this is going to be a cash outflow. I'm going to give it to the seller of the car. So it's minus 50. I've already placed a 50 sign, minus sign. 50k divided by 1 plus r. What's the power? What should be the power? 5, and 0.07 is the rate. So if I solve this equation, I am equating this to 0. If I rearrange and solve this problem, so solve it for CF4, I am going to get the value or the amount that I'm going to save in the future cash flows. In year 4 to meet my requirement of 50,000 at the end of 50 years. Similar problems may be asked. Moving on. So if this doesn't, if this is not 50k, and I am saying that I would be needing 10k more, and I would be needing 10k more, and I would be needing 10k more for the next 3 years, right? From period 5 to period 4, 6, 7, 8. So I would be needing 10k. Yeah, I mean, I would be withdrawing 10k out of my account, right? And this is also a cash outflow. Again, this is a perfect case of an annuity. What I would do is I would try to find out the present value of an annuity from period 5 to period 8. There are 4 cash flows, and I would get the value of the annuity at time period 4. And the time period 4, I would discount it to, once I get the value of the annuity using that formula that we have discussed earlier, I would be able to discount it to time period 0, because we want it to be net present value at time period 0. Again, I can equate it and I can solve it to find out the value of CF, but we are pretty sure that this time the CF is going to be quite high, because I'm needing 10k, 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 40k against my deposit of 25k. So I would be needing something around some bigger number, maybe 10 to 15k, to be able to meet my withdrawal needs. So we can find out the absent cash flow very easily in such kind of arrangements. So let me conclude it here. I believe I've given you enough. I hope that if you apply the right formula and the right approach, which is very simple, you're going to do good in that. So best of luck. Thank you. Bye bye.